Hey everybody, welcome back to another video. In this video, we'll be going over the decision tree algorithm. What is the significance of the decision tree algorithm in the broader world of machine learning? We'll be going over when do we actually use or when should we specifically rely on the decision tree algorithm? And towards the end, I will be demonstrating to you an application where we are leveraging a model that is built on the decision tree algorithm, and we are predicting a specific variable based on certain input features. So without further delay, let me introduce you to the decision tree model, the decision tree algorithm and its significance. So we can use decision tree for both classification and regression based tasks. Fundamentally, we want to use decision tree, or we generally use decision tree when we have a bunch of data points in this in space, and the decision boundary that is used to classify those points effectively or predict a value in the future relies on the effective capturing of the meaning behind those data points. And sometimes a very rudimentary algorithm like linear regression or logistic regression are not able to coherently capture the convoluted patterns that is replete in those data points. And therefore, in those situations, we use the we use the decision tree logic. And as you can see, this is a very colloquial example of decision tree used in the classification task. So based on the different features that we have, we choose one feature at a time. We put specific condition at the node, and then we classify the data points based on whether those data points meet that particular criteria or not. So in this particular scenario, we are starting out with the age vector, and we are basically moving towards the left if the age is not greater than 30, and towards the right if the age is greater than 30. Towards the left, we are basically then we are judging the decision based on the income, and towards the right, we are judging it based on the credit score. Now, how are we supposed to choose which feature should we give more importance to? That I'll discuss in a bit. But essentially, the logic behind decision tree is exactly this, that you pick one feature at a time, you parse through all your data points, and you gauge and you see which data points satisfy the condition which is implicit in that particular node. And then accordingly, you slowly and steadily move down the decision tree towards the leaf nodes. So having said that, let me quickly go and explain to you how do we actually decide which node should we give more priority to. And it comes down actually to the fundamental concept of purity. So essentially, we use three different metrics, or we can use three different metrics now based on what kind of decision tree that you're trying to build, and or what algorithm are you trying to leverage, or what framework you're trying to leverage that is already present in scikit-learn. So for example, if you're trying to use the CART algorithm, which is classification and regression trees, then you would inexplicably rely on or sorry, rather inextricably rely on Gini index. On the other hand, if you're relying on something like ID3, in that situation, you would rely more on information gain and entropy. So we basically measure purity of a particular variable, and then we decide which variable uh, has the least impurity, or rather the highest purity, and accordingly we decide the priority of the nodes. So one of the examples of purity can be if I have a variable, say x, and it has two values, 0 and 1, I would be in a very high purity state if all of my values in the data set are aligned to one specific category. So if every single data point in my data set falls under one of the classes, or it falls on the other classes, or sorry, or rather it falls on the other class, in that circumstance, I have the highest purity. On the other hand, I have the highest impurity if sort of my data is, you know, is split equitably. So in one class, I have 50% of the data, and in the other class, I have 50% of the data. So in that specific circumstance, I can say that, okay, this is the state of highest impurity. Now moving on, So one of the things that we usually encounter with decision trees is that usually decision trees work really well when we have a decision boundary that is sort of more convoluted than a straight line, like you see in this particular scenario. But sometimes when we are training a decision tree model, it can become extremely susceptible to overfitting when it is really well trained on the training data. And so we need to make sure that when we are designing the decision tree, or when we are deciding what kind of decision tree do we want to do we want to leverage to train the model on the training data, we need to specifically decide to what degree do I want to train my decision tree on my training data? Because if I train it more than it's needed, it will definitely overfit. Therefore, we need to do something called pruning slash hyperparameter tuning. And we have a bunch of hyperparameters that we can use to decide to what degree am I willing to train my decision tree. And these parameters uh, decide what will be sort of to what degree I'm going to decide the depth of my decision tree, and to what extent I'm going to be training my decision tree on the training data. So if we play around with these features really well, and we sort of do this in the pre-pruning task, uh, a good balance of some of these hyperparameters will give us the best output on the training data in a way that it does not overfit and it performs well on unseen data as well. And we also have a refining that we do in the in the post pruning stage rather. And one of the interesting observations with the decision tree is the more depth you have in your decision tree, the less you reduce the residual error in the in the evaluation. Whereas if you have sort of less depth, then your residual error kind of increases. So there's an inverse relationship between the residual error and the tree depth. And so the task that we have at hand uh, vis-a-vis overfitting is to sort of find a balance between to what depth do we want to go versus how much residual error are we willing to compromise. So this offset between depth and residual error will eventually decide how good our model is in the first place. And this is sort of a graphical representation of that. And so having said that, having said this, let's move on to a very peculiar example to basically demonstrate to you how you will be, applying decision tree in a real world use case. Uh, so in this particular example, I have trained a decision tree model and I have saved it in best decision tree classifier model dot joblib. And essentially in our data set, what we are trying to do is we're essentially trying to predict the duration of stay of a particular patient using age, dosage, duration, and the indication. So these are the variables that we are using to predict the duration category. And as you can see, we have split the data set into train and test. We have trained the model, and post-training, we have saved the model in best D2 classifier model.joblib. And now this model is saved, and we will use this model in an application to predict the duration of stay. So in a real world application, you can get a use case something like this where you have a a case study or a report where you have been given multiple case studies, and in those case studies you have specific values of dosage, you have specific values of the age of the patient and other input variables that you need to basically predict the duration of stay. And based on this report, someone can ask you that, hey, I want to predict how many days is this patient going to be in the center or in the hospital center. And so in that specific scenario, what we have to do is that we have to extract the input features from the source document, and we have to pass those input features to our decision tree model to be predicting the duration of stay. And to do that, actually, we will be leveraging something very interesting. As I mentioned at the beginning of the video, we will be leveraging the ability of our large language models to read through and parse through PDF documents and extract specific values uh, from this particular PDF that we need. Now, under the LangChain framework, we have a very interesting uh, pydantic feature that allows us to basically pass a structured output framework to our LLM. And the LLM always follows this structured output framework when it has to extract and return to us specific values. So this is kind of a broad strokes architecture or a broad strokes explanation for it. So you have a bunch of unstructured data in this time, in this particular case, in the form of a PDF. And this basically your LLM is acting as a conduit, and the API through which we'll be calling the LLM will extract the necessary input features that we need, and it will then pass those input features to our decision tree model to be predicting the duration of stay. So to give you guys an example, this is uh, an application that I have developed, and so I will go ahead and I will upload my case document. I will do analyze case study. And while this is running, let me quickly go to Google Chrome and actually show you where you can find this code. I will be linking the code in the post, in my LinkedIn post and in my Medium blog as well. But just to demonstrate to you, you can go to my GitHub and just go to ML dosage analysis. This is where you're going to find the code base for this particular project. And if you want to sort of read through the various different features or the various different techniques that are involved in designing and developing this application, you can also go through my Medium blog. I have pretty explicitly and you know very I have sort of explained every single aspect of this project in greater detail in this Medium blog, so you can take a look and you can read through this blog. So I believe in the meantime we would have gotten the results. So for example, you can see it extracted the details, it put the details in this particular section, and it passed those details to our LLM, and this is what the LLM predicted. So less than 5 days for case number one. Similarly, it predicted for case number two between 5 and 10 days. For case number three, similarly. So this, as you can see, is an interesting use case where we have basically predicted our uh, duration of stay based on the input that is part of the case document. And so this was one of the interesting examples or one of the interesting use cases that you would find in the industry where you will have very unstructured data. You have to develop a pipeline that will process this unstructured data and predict something. In this particular case, we had to extract specific input features because based on those input features, we have trained our decision tree model. And once we extract those input features vis-a-vis through our LLMs, and we pass them to our decision tree model, and our decision tree model then finally predicts the predicted duration. And you can upload, and one specific document can have multiple case studies. So I have given the system prompt in a very meticulous way to make sure that the LLM takes into account the number of case studies that we have. So this was it for this particular video. Let me know what you guys think, and provide me your feedback. I will make sure that I will take all your feedback into account when I'm presenting my next video on a different topic. Thank you so much.